So hi everybody and welcome back to the C++ tutorial series for absolute beginners. This is video 224 and in this video we continue with our exercise and we creating our flowchart. But before that, here a fast repetition. In my last video I showed you that you really need only 3 shapes plus 1 special shape. The 3 shapes are the circle, which is our start and end point, the rectangle, which represents actually the whole code, but we have of course one more shape, which is a special shape, which is a condition. All keywords with condition, because when you use a condition you can change the path. You see the normal code is not changing the path, which means it goes in and then it continues here. That is normal execution of code. But when we have a keyword with a condition, and the condition we will write here in the middle, and depends on the condition we have to choose the true path or the false path, and we have to check all time this path. And actually that was our 3 shapes which you really need to know. These 3 shapes, and you can make easy a flowchart. And here are some more interesting rules which you have to consider, which is every path you choose, for example this is my start point here, every path you choose must have an endpoint. Endpoint means, like I said, this circle here is a start. We have one start point, but we can have many different endpoints, right? Here is our endpoint, and when I go from here down to this way, here is another endpoint. And I can start here again on top, go here, this time this way. And here is an endpoint, and so on. You can see every path which you choose must have an endpoint, but of course this endpoint means not the code has successfully finished all things. We know there can be an endpoint which is an error indication, but it is still an endpoint. It indicates just there was an error in your code. And I showed you this as well in our code. For example, here in my sort algorithm, when I throw an exception, this is also an endpoint, because you say, okay, stop here, anything strange happens. That's why I indicate this here perhaps again with a circle, because like I said, the circle here represents start and end point, but we write perhaps an arrow hint so that we know an indication. This, in this case, there was something wrong, and the other ones, it's a ordinary normal flow. All right, and let's talk about this special case here again, this one. And this is not official. This is just what I use. They have other signs for it. And what I did here is just combine these 2 shapes in it. And why I'm doing this? Because I want to skip code, or I have already checked code. So you can see this symbol here means check separately. Check separately. You can check this code first. You can check it before you check the other code here first, or you can check it later. So we have 2 options here. And I want to show you this now in this in our code in a moment, but here one more word. You can see when I say here first, for example, and I have this symbol here, and I indicate here it all time with this special endpoint, but of course it must be not an arrow here. This is just an endpoint. I made here just an example. It could be also a normal endpoint. So important is it has an endpoint which you have checked separately. Very important. And important is now right now you can check it first, or you can check it later. And now I make for this one here an example with our code. So you can see here is our sort algorithm, which we already wrote. There are many mistakes still in it, but okay, now I show you the flowchart, how to use it. First of all, I say, hey, this is very big. I would not check all at start, because if I would try now to make a flowchart for the whole thing, that could make it very not visible, right? If the flowchart or the program is too big, you don't want to make it too big. You're trying all time to make something small so that you can watch it, understand it, and that's it. Because a flowchart should help you, not confuse you. And if you start to make a big flowchart with many nodes, that will more confuse you than help you. So our goal is all time as simple as possible. And one way to do is to create exactly this kind of stuff. This skips chart. We make some blocks which we watch first, and then we watch later the other code which we need and just include this here. This is one strategy, but there are different ways. I make it so because my goal is all time make it as simple as possible, because simple things we understand more easy, and a flowchart should be help you, right? Okay, and then I say, okay, how I can make this big code here. My sort is just one function. You can see the sort is just one function, but this function is a little bit big, a little bit too big actually for my flowchart. So what I do is, let's split this up. We see here the while loop here is big. Okay, then I can say till this while loop, I want to check the code first and then see if I make the while loop later. So what I can do here is say, okay, you can see the while loop is here again, a code for itself. We have to check this separately, but till the while loop, you can see this one, I can already check. With other words, I can exactly create this block here, and this time I check it not later, I check it first, and then I can use this block here later when I create, for example, check the while loop or so on. You see what I'm after, right? I try to make it as simple as possible. Now I skip here the while loop because I don't even watch it, because I start with the checking this one, and this one I can make here also a checkbox, but for later. All right, let's see how we make this. All right, I make here this paint because I said as easy as possible, because that's the reason why I make this. And let's use our shape. The first thing we need is all time our start point. This is the start, and the start point indicates just I start here, which is actually my call of my function here. This is my start point. I call this function. And what happens after this call? You can see this one is just code assignment. Okay, here I assign code, and then I have a check. So we can make this one. First of all, you have now to read, of course, if this assignment and all what you want check here is right. Actually, I have here already a problem, which I indicated here in this comment. I wrote here, I need check first if head linked list is null, PTR, and react to it. Which means you can see the head, what is this? Head linked list, this one here. Probably I mean this head linked list param here, so I should write this right. Head linked list param is null PTR and react to it. Head linked list param not checked. Yes, this one is the right thing. This one here is not checked. And why can this make a problem? You can see if this is, for example, not if this is already a null PTR, it means there is no list, because my head of linked list param must have a node in it to say, which indicates there is a list. If there is no node, it indicates there is no list. And at this point, I have not checked it. Just so now we have checked this one. And in the second point, interesting is here at the if condition, I'm checking this one. So here, head of linked list unequal to null PTR, you go in, else you go here, and this throw here is indicating we have to write, of course, comments. You can see I have two less comments, bad practice. Write all time comments to make it sure, because if you read now this throw, what is this throw? Do you know it? No, you would not see it. So I write here a comment and say not throw, right? Not throw, just write the meaning of this throw, and the meaning of this throw is there is no list, something like that. And of course, let's write more comments. Of course, you don't need to use throw. That was just for exercise. Normally you would not use here throw. Why not? Because throw means all time terminate, right? We are terminating the program. We don't want normally terminate the program. We would rather program it so that we ask the user to do another, to go to the user interface and say to the user who are typing anything in that he should define a list or find a list or just quit. So you can give him options what to do after this, so you don't have to quit the program. But in this case, I wanted to only show you this try catch block, that you can make this, but in real you would not use here a try catch block. That was just for exercise purposes. But let's go back to our in a moment, we will go back to our flowchart, but before that, this one here, we can also solve in different ways. For example, I just could put this one here below this code. Like I said, order is important, because what happens if I put this code here below here? Then this one here, this if one will go in, right? It will check for null PTR. If it's not null PTR, it will go here. If it's null PTR, I would already have here a throw. So with other words, this here is already a null PTR check for the head list param. So if I would just change here the order, you can see that was an easy mistake. It was not a big mistake, but I can solve this in an easy way. And there are different ways to solve it actually, but this was one way to solve it. It's not the best way, because if you want to still keep it on top, you would have just to check this one separately, but we have here already a check, so I put it just here, and then I have this check. So now let's go back to our flowchart and let's try to model this one. So I said, okay, here's my start point. This is here, the function. Here I start. This here is just code assignment. And here I said this if. All time when you see something with a condition, we have to use the special symbol, this route. But before that, we have normal code assignment, right? And normal code assignment is our rectangle. So let's make the normal code assignment. And I make it here a little bit simple, not to take too much time here on the video, but you understand it, because that's the nice part. Even I make it simple, that's the purpose of a flowchart, to understand it easy. And here, this is our code part here. I keep this one here, and then here we have a condition, and I said all time when you see a condition, because the path can change, I can choose now the true path, which would be the body here. The else path would be in this case the part here, but sometimes there is no else, which will be lead just to normal, continue the flow of the program. But all time make this one. So if, when you see a if, a while, a switch, or anything like with a condition, make all time this route, and you can see I see one. Now I can choose the true path. I indicate, you can write here true, but 1 indicates true, 0, and you can, if you want, make sure that everybody understand that 1 means true, you can make here a legend. Legend means just an info text. Info, you can write here something like info if you want, but normally a programmer would know it, that 1, but just to make sure 1 is true, then there is no question, right? So 0 is false. All right. So if you write something like that, then there is no question what is 1, what is 0. It says here 1 is true path, 0 is false path, and I think, and then here you write the condition. But before, you can see I made now here a very little route. Normally the condition would be, you have to copy this one here and write the condition here. But you can make now here there are different ways to do it. One way is you write the condition here in, and that's the right way, because you want just read here, and here the same thing here. You want to write the start point here. Then you can read the code here and understand it. But let's say you want just analyze like me and you have opened up the code as well. So then you can use something like just referencing. Referencing means just I say this is pause. You can just write here an indicator where the code which you would write here is here in your code. Right, so a reference, just you can choose what you want. For example, this is pause 1. This is our code. This starts here, and then you can make here, or let's say P1 to make it even shorter. P1 is here. Then you can write here P1. Here it starts. This is P1. This code section you can call, and like I said, this is just for analyze purposes. This is P2 instead of writing all down, so you can see the parts and just compare. And the condition here is my P3. But like normally you would not make this because your goal is here just to read this one, and if you are using this placeholders piece, then you have to read the code here all the time. But still, it's still easy. And let's go on. So now you can see my P3 is my condition here, P3. So this is my reference. And now I can say, okay, I have a true path, and you can see the true path enters here, code execution. Okay, make a code execution. We know code execution means just a rectangle. And else path is a throw, and a throw we learned is an endpoint, but an arrow endpoint. So I make here an arrow endpoint, and then I make here just here the arrows a little bit so that I indicate the thing. Here you can write again the code execution, a new P, perhaps P4, but you don't have to write it every day by everything, but you can make it or not. It's up to you, because the goal is just simplify it and understand it. This is P4, and this is my error, P5, and here I have to write error as well, because I want to indicate that this is not a normal end solution. I mean, it is an end case. That's why we have the circle, but I want also see that here an error occurs, right? In my case, normally you should not use, like I said, we could use here also a normal something else. Instead, for example, go back to the user interface and give the user options to continue or just add a list or anything else. So we don't have to use this. This again was just for exercise purposes here, but still, and you can see we can indicate this one if you want. Just write here some more information, because you can do whatever you want with this list here, because it's for you. Error. Because this here you make for your own understanding, right? And then you write here this one in, and then you can see we have here still 2 new assignments. Let's take this together as well. I make this one here for this both here. Let's call this here P6. Let's make this one here P6. And interesting is now the question, wait a minute, how I can go on. Now I used here this route here, and this one, this else statement, you can see is an error. This will not continue. So here you can't continue, because end statement means you can't continue. All right. But what happens with the other code, the true code? The true code is this one, and true code means, wait a minute, after this condition is true, it will go in, and when this is finished, it will just continue here, which means we can go on. And go on means just here, we go on with the code. And the next thing is P6 is again normal code execution. Okay, then we make a normal code execution, for example. I write in P6 because that's my next one. And this is again a reference in P6, and then I'm almost finished because this part is finished. It will go here to the while loop. Yeah, so with other words, you can stop here if you want. because the while loop we will not start it, right? Right now, this is one block. So let's go here. We make it very easy. And then you can indicate it like you want. You can use it here. Also, you can stop it here. But most time, many people won't stop here in the middle because it looks more symmetric. So, and here we have a stop. And that's it. That's the first part. And you can see the first part here is now, the question is now, okay, how does this help us now? The helping is now when I try to explain you here this little start position, now you can say, okay, we start here with this P1 means just calling the function. P2 means just assigning here the values, and then you decide if this, okay, the only thing which is really missing here are many comments. You can see I have not comments normally. Where all the P's are, you should write an appropriate comment so that the people who goes to this reference positions, for example P1, and then he can read also the comment here what it's doing. So for example, if anyone sees the position P2, for example, here, jumps here, say, okay, you are creating and assigning pointers, but he would ask why you are doing this, right? The question is here why you are doing that. I mean, that's the reason why you make your P1, P2 section, and then you have to write a comment which describes the reason why you make these pointers. And I would say this pointers are used for comparison, something like that. Comparison, the linked list values, something like that. So that this here should describe the reason why you make this, not what they are. Everybody can see what this is. This is creating a pointer, assigning to nullpeter. They can read this, but they ask themselves when they read, okay, why you are doing this? For what? What is your goal? And this kind of stuff you have to write in the comments why you are doing this. And the same goes for P3. Again, we can see, okay, P3 a condition, but again, no comment is bad. The people who is reading now P3 say, okay, what you are doing here and why you are doing this. And then you have to write here a comment again. For example, check if there is a list and assign. Check if there is a list. It's not enough. Check if there is a list. This is the check here, and then assignment come here, the next comment, and then you can make so on. But you get the you understand what I mean, right? You see that my commenting here is very bad. The same goes for P1. There is again no comment. The people who reads this function says, okay, the name is good of this function because it says sort linked list like bubble sort. So it's indicating he understands, okay, this is a sort linked list like bubble sort, but still you have to describe it, a comment. So why you are doing this and what you have to do. Let's make it short here. I write here, yes, sorting list, something like sorting list function, custom made, yeah, custom sorting list function, because let's write in custom. And the reason why I write here custom is because there are many official sort algorithms on the web. You can use them. And here I wrote custom because this was just made up of my mind, which means most time when I write custom, most time it's not optimized, right? You can see I have just created this code right now on the fly. There are many bugs in it, not optimized, because the other sort algorithm which you find on the web, millions of programmers have reused them, optimized them, and that's why they are very well known and in many different ways. But when you create your own, then you have to optimize it on your own, check it on your own, and that's why we have here also some bugs in it, and I will show you them later on. But right now you see, commenting very important. And you can see now also why I say it is important that you not describe when you're commenting what the code is doing, because like I said, everybody who knows the basic rules, so basic keywords, can read this and understand this, but they ask the question, okay, why you are doing this, or why you are creating this function, or why you are creating this if clause, because they can of course read this, but that takes a lot of time, and sometimes they even don't understand it. Even if they read the code here, it's not all time clear, and that's why you make here a comment which makes it clear and the reason why this code is here. Most time this comment should answer the question why you are doing this, not what it is, everybody see it, but why you are this is, and yet what is the reason to do this code here at this point. And we go back to our flowchart, and with this set, so if you have here good commenting, you can see everybody sees, for example, okay, let's try this one more time. P1 is a custom sort list function. You can see now I read here the commenting, not really the function itself, because I jump P1 and then I read the comment here. Custom sorting function. Okay, here starts the custom sort function, P2. Let's jump here to P2. Oh, pointers are used for comparison to linked list values. Okay, this code block here, whatever here is pointers are used for comparison to linked list. So you can see I use here the commenting in this flowchart more than the code itself, because the code is just the thing what you have to program, but the commenting is actually describing all this part. And then we go to P3 here in this part, and it says check if there is a list. So this whole P3 part is okay. Now I can see if it's false means there is no list. If it's true, there is a list. And then again, I have to comment this out. What is P4 doing? You can see here. Right now I see nothing. Again, I need a comment to understand it. There is, so why I make this one here? I can see it is again a pointer. It is assigning to the next one. But the question is all the time, why are you doing this here at this point? And setting, the reason why I do is need to set the second pointer to second position. Position. That was our pointers, because we have swap pointer second position. You know, we have here 2 pointers created here on top, and this one sets to the second position. Okay, this is too less comment, but I think you understand it. So you can see again the people who watch this list here says, okay, P4 is, and then he reads not this one, because again he can understand this code here, but still he has the question, why are you doing this? And then the comment is very valuable, because the pointer said, okay, set the second pointer to the second position. Okay, and you can see it becomes really easy to go. And P5, okay, this arrow we already covered. There is no list. That was this arrow. Okay, good. And P6, so the next question, okay, here is a comment. And P6 was this code here, and it says why you are doing this again. At link swap pointer. Again, here I have to change here the comment, because I corrected this one. This comment was before. Now the comment would be normally assign first pointer to first position, something like that. Here we have the second position, here the first position, and you can see this a little bit messy, because normally this check here, you could make this check here separately if you want, so that you understand this a little bit better. And yeah, okay, this one is assigning the second position pointer there. That was here P6. Actually, I have here one more. If you want, you can go here and make here one more if you want, or you can just say, just skip it as P6 and write here also a comment, so make it together. And then you can say here node loop and position pointer assign. Yeah, create here, create loop. loop pointer yeah, create loop pointer. So the point is here, what you have to see is comments are very, very, very important here, because you are not watching here like I showed you the code itself. You are more like you saw I skipped more or less the code what we have, because I try just to understand what I'm doing here. And when I see this one, I read the comment, okay, because that's the goal, right? We try to understand what is this function here doing. And now I have finished the first part. I think I understand this one. You can explain this one, right? That's the point. For example, if you have a kind of team colleague, and then you say, okay, you go here, start again, P1, here is a custom sort function, here assign at P2, I assign here the values, P3 I make a check, and P4 I make here assigning the value. In the false state there is an error because I expect a list, and you can see how fast this is when you get the routine. You can see I was now much faster than the first time when I explained you it. And that's the goal, that it's very easy to explain. And we are not finished. That was the easy part, actually. The easy part was this one. And the reason why I made this one is, when we go back to our other graph, here I created now this part here. And I made this first, right? I created now this part. And now I can make the whole thing what I have here. I convert this one to this block here. And the reason why I can convert this, because I have finished this. This one you would save anywhere. Now you can create, with other words, you can summarize this one like this block here and write here a label, which indicates that it is referenced to this here. And then you don't have to use this when you tried, for example, to use the while loop. So we split it, the complexity, we can say. We made it easier to understand. Now I understood this part separately. Now I can go here to the while loop and make the same thing. The while loop looks also not very easy. And then you can split this whole part again and make this. But let's make here an indication. Like I said, this one is finished at this point. You have to, yeah, let's make it. So this one is finished. You can save this anywhere. And then when you start the next time, you can make here a label about it. Like I said before, this one, you can create this and here this combination about this two signs. And let's call this one the whole thing. You can give it a name, whatever you want. For example, start position, start of. Here you need a new name for it. And let's call it whatever. Let's make here this one too. Let's make here the endpoint, because everything has an endpoint. And we call it, just for fun, anything what you want. It is just a name for this flowchart, the first part. Let's call it first part of the sort linked list, like bubble sort. I just wrote here the function name. That's why it's so long. Okay, that's what I did here is just I write first part. I should separate this normally, and here the function name, so I know the first part of what. But this one is just a name which you come up with your own, so that you know that this one here, when you use it later, for example, if I want continue now here with this part here, with the while loop, what I can do is then in the next video, I can just say, for example, let me show you this one. What I make next video, very easy. I take this part here because we just finished this one. And then I say, okay, the while loop here starts after this one. So I can say here, the while loop starts after this one. This is the start point. And Normally you don't see something like this one in other videos. And the reason why you see it on me is because it is just a continue, right? This one is not a real start point. This is more an indication of a continuous, because it is the start point from the next while loop. And then I would the same thing do here again. All right. You can do something like that, but normally what you do is, or let's say what they officially do, I think, is they don't make this one here because they say this is the start point. But in real, this one is our first part, right? And then this code follows. And because this one we have covered, if there is an arrow, you can see this one here, there is an endpoint. This endpoint here is this part here. You can see this here goes actually here, continuous. It's more a continuous point, not an endpoint in this case, but here I just watch this code. And this here is my arrow part, but of course there could be another endpoint. For example, you can make here a break. Must be not an arrow, there can be a break here. But important is that in my next video, you could just start here and continue from this point. And the reason why we make this, again, that's very important. Why I make this whole thing? Because I don't want to make a big graph. You can see here, I made this graph, right? And the next while loop, that looks even bigger than this one, much, much bigger. And you want not make something very complicated. Your goal is, again, very easy to understand, and the comments here, you just read the comments, understand the code within some minutes, right? With this if you have good comments here, this explanation, you can explain a code in some minutes, and the other programmer, oh, that's easy. And of course he expects that all the code is right, because he's not really watching the code, he's more watching your comments, what you are trying to achieve. So with other words, the code should be right here. But we will still find some bugs, I think, in my code, because when you do something like that, you have to check your own code. The person who is creating this flowchart should check his code, of course. All right, I think this is so the part one, which where I want to stop. And again, this one is probably what you not see normally, because normally you will see all time. This one is as indicating of a start point, but again, this one is just a continuous point in our case, because our goal is to make the flowchart as easy as possible. And that's why this one here, when I create here this while loop, for example, would also later be something like this one here. So when I finish the while loop, it would look something like that. I finish this one. Where's the next one? Here. And this one. And then I would connect this one here. And you can see this is a code execution, right? And then I would connect this one. This would be the while loop. This is the first part. And of course, this one has this arrow, and then it looks more normal, right? This is the normal look. And this one here would one more endpoint, because everything needs an endpoint. In the end, this one looks like this anyhow, right? So this is the most simplified version. First you make this part. Perhaps you can even split this one in some parts. Then you have here some more of these blocks, and it looks very simple. And every block you can check for its own, understand for its own. So super complex code, you can simplify it, make it easy to understand. Of course, you need then just a good naming here, labels. Labels mean just names which reference this block, and then and good commenting then where you can read this, and then you understand very complex code in a very easy way. That can help a lot with big projects. So with smaller projects like we do as a starter, probably not so, because in our tutorial here we are using all time these little codes which are most time easy to understand. But when you see something starts to get big, so you can see this function here is normally a bigger function. It's not so small, it starts to get bigger than the normal ones. The most function which we create was just print out a value or sort and finish. That was all time so 3 lines. And now we start to get more and more lines. Then you see it's not so easy, but still this function is not too big, still manageable, but there are some more difficult parts. But if you try, for example, to understand now the whole thing here, not just the one function here, but the whole thing here from main to all the side things here, then and try to, yeah, that starts to begin a little bit more complicated, I think. And then this kind of stuff can help, must not, but can. And it's all time to good to know. And I think that's good for this video. And we can go, I think I will try to model also the while loop. Probably we have to split this next while loop because it is big and there is a bug which I want to show you. And yeah, with that said, if you have any questions, any comments, like all time, write into the comment section. And I hope you try this also on your own. You can see the flowchart, it's really simple. There are 3 symbols, shapes, which you need, this. And important, comment, very good. Commenting is very important here, you saw it. Because if you have not a good commenting, this flowchart will not work really, because they are not really watching this code. The point is you want not watch this code. You want watch this comment and you expect that the code should work at this point. That's why you can read this flowchart so easy. You read this comment like a text, and after you read the text you understand the whole code. All right, see you in the next video. Good luck, and of course try it on your own. Very important. Not just understand it, try it, make your own, and see if this is helping you. Check on your own if it's helping you. If not, then skip it. If yes, then use it. All right, bye.